on N. Okay, join them. So put an example. Let's say this signal is the stock market in the US, right? The stock market in the US. So that means every day it has some price, some stock market index. And of course it is, we cannot predict them. So let's assume that it's a random signal. And this is a stock market in Vietnam, right? So we can define them jointly here in the sense that we can describe it. So, they need to be jointly have some behavior. If the stock market in the US going up, then likely this one will going up maybe in a few days. So you see that. And we can describe them jointly. Okay? So you have two processes that somehow they are connected with each other. And the way to describe that relationship is by a system here. Okay, maybe I should put the name here. So this is a function called cross correlation. This is a cross correlation function, right? We do define the cross correlation function. Cross correlation function. Alright, this is a cross correlation function. And to describe the relationship between two random processes or random signal, many times good enough to just have this. And this, we have the name, this is auto correlation function. And this is just a mean. Okay. So I apologize. The thing really should have to be correctly here. What we say here is autocorrelation function. Originally it depend on any two samples, but now it only depends on the distance between them. And similarly, the autocorrelation function or the cross-correlation function. Okay? Still okay up to this point? Everyone, alright. Alright, so now we want to take this concept and try to study a simple operation. And maybe I want you to take out a piece of paper. I want you to start thinking about this. Okay. So let's say I'm going to have a filter. HN. And beside this filter is fixed. Fixed or deterministic. So this is a constant filter. I have this filter fixed. Okay. So I have a fixed filter, like a filter I design, and I put it out there to test. And I give it out, and people put in the signal, the input signal. So people put in the signal here is the signal XN. And I assume the input signal is a right-hand stationary process. Right? So this here is a signal that is it's a random variable. I don't know what it is. X instant account, but I can describe it using these two quantities, the mu x and the delta xx. Okay? So I put this in here. So a random variable and the output y of n here. N is asked me right before summation. Okay, before that, let's say, okay, I define this. So, give me a signal, I can compute an output. Right? Give me a signal, we get an output. And h of k, x of n minus k, go from minus infinity to plus infinity. That's not difficult to see, right? That's the conclusion. And again, this is fixed. So this is a constant. But this thing here is a random variable. So this is every different instant of time. So I have x here. You know x here is not just one realization, but it represented many different realizations where I have a random probabilities. So obviously, if this is random, right? Random, then this thing has to be random as well. Okay, so I put something randomly in here, I get something randomly outside. Now, so now the question is given now, I have the gamma of x of m, because x is a y-stationary process. Given that I have this, which is defined like this. Given this, we want to find what is the expectation of y of n minus n. Right? You see what I have? I have this random signal coming in, go through this deterministic filter, I get a random output out. And what I want to look at is this random variable, like one of this, what is expectations of the product of this signal and this one? Right? So I wanted to take a piece of paper out and maybe try to stress out some derivations. Can you simplify it? What can you simplify this? Summation now in L, and I have h of k, h of L, and then x of n minus k, and then x of n minus L. Okay? So when I see this, again, I tell all you all, you need to identify what is a fixed, constant. This is a fixed. This thing is a constant, right? This is a constant. Okay, so the expectation is the sum. We sum the expectation, those linear combinations. Right? But I tell earlier on this linear property of expectation. So I can write down now that is summation in k, summation in L of h, k, h, L, taking the expectation of x n minus k, x of n minus L. Is that clear, anybody? So what is this? What is this thing? It is autocorrelation of this and this. And what you need to do is the autocorrelation, because x is the y-stationary process. So this autocorrelation here is only depends on the difference between these two. Right? Doesn't matter what n is. It just difference the difference between these two. So now that equal to the summation still in k and L of h k, h of L, and who can tell me what is after thing? Gamma of x of what?
M plus L minus
I take M
plus L minus